All right, guys, Mr. Jenkins here. So you'll start to see more videos like this instead of generic YouTube videos of me kind of filling out the notes that you'll see as part of your lesson. This will be the first lesson of Chapter 2, 2.1 about relations and functions. That shouldn't be there, so I'm going to mark that out. Your learning target is I can identify a function from a table, graph, etc. So being able to identify a function. Also, there's some stuff about domain and range in here. So just basic stuff about relations and functions. So first of all, some definitions. What is a relation? A relation is a set of items from two sets. A set of input values and a set of output values. Now, there are some synonyms here that you need to be aware of. Input values are also known as X values and also known as the domain. Output values, also known as Y values, and also known as the range. All right, so now we are going to look at different ways to represent the following data. So example 1, sorry, this thing, you'll have to bear with me on that. Example 1 says the monthly average water temperature of the Gulf of Mexico and Key West, Florida varies during the year. In January, the average temperature is 69 degrees, February 70, March 75, April 78. So basically represent this in different ways. So as ordered pairs, we're just going to identify what the input values mean and what the output values mean. So here our input values will be our month. So month is represented by the X value or the input value, and then temperature will be the output. And the reason we know that is because temperature depends on month. All right, so the first one in January, we're at 69 degrees. So January is month 1. So that's 1, 69. Or we could say 1 goes to 69. 2 goes to 70. 3 goes to 75. 4 goes to 78. Okay, so that's one way to represent those values as a set of ordered pairs. As a table, very similar look to this. Still, we're going to stick with input is, I'm not going to rewrite it, but our input is months and our output is temperature. We've already kind of talked about that. So again, 1 goes to 69, 2 goes to 70, 3 goes to 75, and 4 goes to 78. On the graph, you do need to be a little bit careful here because, well, our output values, they start at 69, right? So, and then they're in a pretty tight range. So hopefully that stops on the right spot. Sorry about all that. So what we want to do here is use what we call a line break. Okay, so we use a line break here. That's basically how you skip a part of the number line, and then we can count by whatever we want to count by. So I will just count by, I'll just count by ones from there. So we'll say this right here, we're going to start at 68. This could be 69, 70, 71, 72. Notice I'm labeling every other one just to keep it neat. All right, and then we just need to count by ones on our x-axis. skip that one, go 2, that'd be 3, that'd be 4. Okay, and then we're just plotting points, that's all we're doing. So again, 1 goes to 69, would be right there. 2 goes to 70, would be right there. 3 goes to 75, 3 comma 75, and then 4 goes to 78. There. So that's how it would look as graphically. And then the last thing you have is a mapping diagram. We won't really use a mapping diagram, so actually I'll skip that. You can see what that looks like on your notes. It looks a lot like a table. So skipping to the next page. What is domain? So the domain is the set of input values, or X values, or what we call the independent, another synonym for you. All right, and then the range is the set of output, aka dependent. All right, so example 2, what are the domain and range of this relation? So guys, any set of ordered pairs is a relation, right? So, but not every relation is a function. Okay, so for this example, my domain, and this is what we would call a discrete function. It's not continuous, so because it's discrete, we're gonna list just single numbers. I guess the important thing is, getting a little bit ahead of myself, that you don't write repeats if there are any. All right, so my domain then is going to be all my X values. So -3, 0, 2, 9, and 23. So there are no repeats. I like to put them in numerical order too. They already are, so I'm just going to list them as I see them. -3, comma 0, comma 2, comma 9, comma 23. So domain, and then range would be all the output values. So 14, 7, 0, -18, and -99. You can list them as they are, but I like to go numerical order. So that's how I'm going to list them out. So in from least to greatest, that would be, all right, you want to put your brackets to start. That's how you do a set of numbers. So least to greatest, we go -99, -18, 0, 7, 14. So pretty simple there. There are some other types of examples that can be a little bit trickier, so I'm going to kind of handwrite those in. They're also on the filled out notes. So it becomes trickier for a continuous function. So such as, let's just say, we'll call this example B. We have our graph there. And so let's say we have a line segment that has a endpoint at -2, -1. And an endpoint at 2, 0. Okay, so for this, you can't just write out like a set of numbers. There are actually there's actually an infinite domain and an infinite range for this. So a little bit trickier, like I said. So for the domain, remember, I'm thinking X values, right? So my smallest X value is -2. My biggest is +2, right? So we basically need to write this as a compound inequality suit. So we say this is going to go from -2 up to positive 2. So compound inequality there. It looks like an and inequality. And then the range, we are looking at y values. So smallest y value is -1, biggest is 0. So we go -1 up to 0. So a little bit of a different beast for a continuous function. There's also an example C on the filled out notes that you might want to look at there as well. So what is a function? A function is a special type of relation where each blank is paired with exactly 1. So before I get ahead of myself, it's where each input is paired with exactly 1 output. Another way to say this is that a function has a, or is, 1, 2, 1. All right, so the question now is, for the rest of these are, is this a function? All right, so when you're looking at a set of ordered pairs, basically you're just looking for does the x value repeat? So I have 2 here, that's okay, but then I have 2 here. So basically what this says, if we're thinking about a mapping diagram, is that 2 maps to -3, but also 2 maps to +3. Okay, that cannot be. So if you're looking at a set of ordered pairs and you have a repeated input, then the answer would be no. Okay, so I'll leave 3B for you to look up or try on your own. Looking at some continuous functions or other graphs. So for this, you would use the vertical line test, right? So is there any vertical line that I could draw that hits the relation in more than one spot? And the answer here on A is yes. You see one right there. Actually, any vertical line you draw this whole way is going to touch more than once. So this actually fails the vertical line test. So this is a no. This one passes no matter where you draw a vertical line. It only touches in one spot. Don't get this confused with a horizontal line test, right? Because if I draw a horizontal line, it fails. So it's not a horizontal line test. And then the last one, C, obviously fails right there. No. So it kind of gives you some tips on how to use the vertical line test underneath, what to do. Whoops, not what I meant to do. Try to pick up where I left off. Shouldn't be too much longer here. All right, I'll leave example 4 for you, more vertical line test stuff. So then the last thing I think we address in this lesson is some function notation. So like we said, the output in a linear equation is y, the input is x. So basically function notation, the only thing that's different is y is written as f of x. Okay, so f of x. So on this next problem, we want to evaluate a function for a given input value. So for 5a, it says f of x is -4x plus 1. So it says evaluate for x equals -2. This might also be written as, you might also see this as, or find f of -2. So that's good to know as well. All right, so we'll say f of -2 is equal to -4. That's fixed. We're going to replace x with -2 plus 1, and then we're going to just evaluate. So from there, you can just punch that into your calculator. That's going to be +8 plus 1 is 9. So we could say f of -2 equals 9, or as a graph, we would say -2 goes to +9. Okay, I'll leave 5b for you. One note on these, if you do plug in a negative and square it, that's always going to be positive. So use those parentheses in your calculator. Last one is going to be a word problem. So I'll do one of these and then I'll leave the other one for you. So looking at example 6, it says you are buying bottles of a sports drink for a softball team. Each bottle costs $1.19. What function rule models the total cost of a purchase? And then evaluate for 15 bottles. So what are my two variables here? We want to kind of define our variables. So what two things could change? Well, we have total cost that could change. And then we have number of bottles that we buy that could change. So which one would be input, which one would be output? So your thought process here is, does cost depend on bottles or does bottles depend on cost? And the answer is that cost depends on the number of bottles you buy. So that means that cost is what we think of as Y, and then bottles is X. Another clue that bottles is X is that it says evaluate for 15 bottles. So you're usually going to plug in for X there. So we're going to use the variable C to represent cost and the variable B to represent number of bottles. And so we would say, we would go ahead and just say that cost is equal to, it's $1.19 per bottle, so $1.19 pops up here. Times number of bottles. Erase that other one. All right, so that looks like a good function rule. That would work. Or on MathXL, they might look for function notation there, so be careful to use what variables they want you to use. So they might say if you're going to use B for bottles, they might say use F of B to represent cost. Okay, so you might also write that as F of B equals 1.19 B. Okay, and then the easy part is last part, find F of 15. So that would just be 119 times 15, 1.19 times 15. Just punch that in real quick. You get 17.85. So final answer would be $17.85. All right, so the rest you can look up on the finish notes. Hopefully this is helpful. Your lesson, your homework for this is section 2-1 on MathXL. I'll post an alternate assignment in the book for those of you who are unable to get onto MathXL at this time. So thank you for your time.